The broadcast is now starting. All attendees are in listen-only mode.
All right, everyone, I'd like to welcome you back to another KevCAM night class tonight. Tonight have Brendan helping out with any questions or concerns that come along the way for you guys. Brendan, are you with us?
Yes, I am. How you guys doing?
And also, oh shoot, we were just talking about my screen issue and now it's back. As soon as I hit the share screen button with the record. All right, so for those of you guys that have been along with this journey, we ran into this last time, but GoToWebinar said they had it fixed. But anyways, also have Greg Payton with us to make sure hitting all the points and filling any of the blanks that I'm missing out for you guys. Greg, are you with us?
Yeah, I am with you. Good evening, everybody.
All right. So tonight we are going to be covering, well, I do see at least a couple new names in here. So just quick housekeeping. For those of you that are new, everybody is in mute just to eliminate any background noise. But, oh shoot, now my screen's really flashing all around. Can you guys still hear me?
Yeah, I can. I can see your screen, Kevin,
okay.
And everything looks fine. So.
Okay. So everybody is in mute just to eliminate any background noise. But if you guys do have a question, definitely send those over in the questions panel, and Brendan will read it off for us, and we'll get those questions answered right away. And these night classes are solely dedicated for you guys. So if you do have a question, definitely ask away, or if you would like to see a different topic for the night class, send those over and we'll send you off some SolidCAM swag as a thank you. So, and as well as all the night classes are recorded. So if you guys go over to YouTube and click on SolidCAM University, you'll see all our previous classes that we've done in here, as well as short little videos, how-to videos that Mark has put together as well. And if you can't find it on YouTube, if you guys go to our website and make sure you got the American flag right here, go to webinars and click on KevCAM Night Class, where you guys came to register. There is a button right here where it says miss the last class, and that will bring you right over to our YouTube channel that we have there. So with that being said, we will get the ball rolling here. And now I got no extra monitors. There we go. Okay, so we've covered in the last few night classes HSS. We've covered linear, which is more geared towards our 0 to 45 degree angles, kind of like right here. We've covered constant Z, which works best with between our 45 and 90, and we also did hatch. So now we're getting into the what I consider the real good stuff with HSS and the power that it has. So what I'm going to do is show you a difference between linear, and then we're going to be covering HSS parallel to curve or curves. So for our first one here, we are just going to do our linear, and I want to show you guys the power that HSS has in here. And let's get some toolpath on here. All right, so now we'll go ahead and save and calculate. Now, like what we've been talking about in previous classes is, how to clean up our linking to make smooth transitions all the way across. So what we'll do is we'll go to our link section, and we have a gap right here. So instead of going up to the clearance area, I'm going to tell it to follow the surface. All right, so we got a nice toolpath going back and forth, right? Now, like we talked before, this is a little bit of refresh, but at the ends right here, we have those square moves. So what we can do here is, instead of doing those square corners right there, we'll do the, blend spline, and we'll get those nice radiuses going all the way through, okay? So now we are basically skipping over this gap right here because we don't need to cut it. So we're cutting air in there. Now, if we do not want to do that and we want it to drive our toolpath lines based off of a curve, that's where the HSS parallel to curves come into factor. So what I'm going to do here is I'm going to just make an exact copy of our linear toolpath, and I will switch this over to parallel to curves. So now our drive surface be the same surface as we clicked on the previous one. Now our edge curve is the curve that we want the toolpath to follow. And as soon as I get this on here, this will be a little bit more clear for you guys. So now, instead of doing straight line movements going back and forth, we told it to follow this curve edge, so our toolpath reflects that now. So now, with that half moon in there, we're not wasting any time cutting air. We're still achieving the same step over as what we had over here, but now we're not, like I said, we're not cutting air. Now, like we did on the other one, we can come to our links, and then we can do a blend spline here. And we got nice clean toolpath. So like I said, we're coming in here. Actually, we're starting at the top, and we're following that curvature going all the way around. So think of it, if you're trying to drive your tool to follow a specific shape. Now, the real nice thing about this is it doesn't have to be actually into the geometry itself. So right here, we have a half moon cutout with physical geometry there. But let's go ahead and hop out of this part real quick.
Kevin, if I want that toolpath to be the same every single time, when you selected those parameters to have the toolpath follow the half moon shape, will those parameters remain there
No.
next time I come around to make that to do something similar?
Nope, so they won't remain there. But if this is something that you commonly want to do, what you can do is, let's say anytime we're cutting linear cuts and we want those, like our links, we always change up our links, and you guys have been seeing me changing up those links constantly through the linear and the constant Z and hatch. You guys can save that out as a template, and then you can also load that as your default template. So then what will happen at that point is anytime I pull up an HSS operation that is parallel to a curve, it will have all those parameters set up for me.
Oh, okay.
So
I could just come back in and just select that template and off I go.
yeah, absolutely. So in here, let's do one. So HSS. And for those of you guys that have been watching for a while, this GoToMeeting just takes my computer to sneeze. Okay, so if we are doing parallel to curve, and in my links section, I always want my links between slices to do a blend spline as well as a blend spline. For the gaps, I'm going to leave, well, usually with a large gap, I have it do follow surface. And that's about it. So that I want these to be a default. So every time I open up a parallel to a curve operation, this will already be set for me. So how we do that is we can save it out and just do parallel curve, and we'll hit OK. Oh, didn't like my name. Nope, didn't like something in here. I may need to grab.
Well, No
Well,
problem, Kevin. You
yep,
don't have to go through the motions. I just
yep,
wanted to know if it's possible to save it. That's
yep.
really all I
So
wanted to know.
when you get all your parameters set in there, then in your settings right here, we can go to our templates and we can go to our HSS and I can pick. So I don't have any templates set up. I'm just going to see if I have any of these. So if I had my template set up, or if I save that out as a template and we are doing parallel the curve, I can come over here and pick my template. So by doing that, any operation or any HSS parallel to curve operation that I start new, it will have all those parameters set in there. Now this will do it just for the local part only, or just for this part only. You can also do this for your global settings. So any new parts that you create will have that default template in there for you.
Okay, perfect. Thanks.
Yep. Okay, so now we're going to kind of do the exact same thing as what I showed you before, and we are going to do our HSS, and we're doing our parallel to the curve. Now our geometry, I'm going to select the surfaces that I want it to cut. Okay. Now the tool path, my tool lines that I want it to follow is this big arc right here. And like I said, this doesn't, all you have to do is you can just do a right click and create a sketch. And sketch can be whatever shape, direction, whatever you want the tool path to follow, it will follow that. So now set up that as our guide curve, I guess you could call it as well. All right, so now let's just go ahead and save and calculate. And we got a lot of bouncing up and down, so let's go ahead and clear that up real quick here. Link. And we got some gaps on the back side, so I'm just going to do a follow surface. And I did kind of forget to start off. So, and I've told everybody in the night class and the previous ones, think of your HSS as a building block. So start with your geometry, start with your tool, save and calculate. Get your tool path on there. So now I can see, you know, I'm not changing 10 different things at once right here. I'm just changing one or two things, save and calculate to get what I'm looking for here. So now you can see, even though that we're going on this linear surface right here, it is following this guided curve right here for my toolpath. So this radius right here is going to be the same down here. So just going back and forth that way. Now, like any other the HSS ones that we talked about, there may be some gouging in there. So what we can do is just go to our gouge check. And for those that are new listeners, the gouge check is basically telling it that we do not want to gouge the part file. HSS,
Kevin,
yeah.
why don't you show the simulation first? That way everybody can see
Sure.
where the gouges are coming from and what steps you're going to take to rectify that.
Turn off. There we go. All right.
Hey, Kevin, is this the new release of is this 2021?
Nope, not yet.
Oh, okay. All right. Sorry, didn't mean to steal your thunder there. If that's
Nope. Soon to come, soon to come.
All right, sounds good.
So you guys can see right now we have a fairly large step over. And that's kind of like what we've talked about in previous classes is keep that step over large, get that toolpath form that we're looking for, clean up your links, and then one of the last things to do is tighten up your step over, and that will give us the good finish. But we'll let this play through. Well, let me see my settings real quick. That's why. Switch over, switch back. I had a very, very high tolerance there, so get this fixed up here. There we go, moving a little quicker now. All right, so now what Greg was talking about is let's see if we're gouging into our part here. And my go-to meeting is blocking. No. So we can see we're pretty close to up to size on our drive surface. Now, obviously, we want to play this through on a much finer step over, but right here, I can already see that when it's doing the follow surface, we do have some gouges happening right here. And let's just hop out of here. And let's go to our toolpath parameters, and we'll set our step over to something smaller now. So we can kind of see a little bit better of a surface finish in there. All right, so we got a much finer step over. And we'll go do our solid verify here.
Yeah, the only reason, Kevin, I was asking about 2021 was this calculation time was really impressive. I mean, but I hear that 2021 is even faster. Is that what I'm hearing?
Yeah, absolutely. And you know, it's I just got to get a new computer for doing these night classes because something to do with my current computer. It's just slow running this go-to webinar here. So usually this would calculate much faster and have much more times going, or quicker times.
Sure.
Okay, so we can see we do have a problem here. Just a slight one, but let's go ahead and do our stock target comparison here.
You didn't mean to do that, or?
Yeah.
I thought that was part of the demonstration.
So now
better cooling, right?
Yeah.
Exactly.
We have a major gouge, and probably the tool would have snapped right there. As well as, let's kind of look back. Oops. To one of these sides here. We can see that we're gouging along our backside as well. So now what we want to do is clean up those gouges. So what we can do is go to our gouge check, turn on our gouge check, and what we're doing, we're telling it is not to gouge into the drive surface. So our drive surface is the surface that we selected that we would like to machine. And with the check surfaces here, I do not want it to touch those surfaces. So what I'm going to do is I'm going to tell it that I want all the adjacent faces to my drive surfaces to be a check surface. So basically, I do not want that tool to touch there. We'll go ahead and save and calculate again here. And now, if we do a simulate, play, oops, hit the wrong button here. So kind of a repeat, HSS will gouge your part just based off of the surfaces. If we're coming up to another surface, kind of like what we were working with when it was gouging down here on the ends, we got two surfaces that are matching up and it's not seeing that other surface. So by telling it to use that as a check surface, it knows that we do not want that tool to be touching along there. So now you can see, one, we saved our ball end mill, and two, we're not gouging through our part now. So now if we bring up our stock target comparison here, you can actually see we do have a little bit of material still up here up front, and that's just my step over that I can change up. But just as an example, rotate this around here. Trying to get this so it's smooth here. We are no longer gouging that entire side that we were looking at before, as well as on the back side here, it was showing us gouging that entire back side, which has now been fully cleaned up. So basically what it did is it trimmed up the tool path to tell it not to have that ball end mill touch any of these faces going all the way around. Okay, does that make sense?
Makes sense to me.
That's all that matters then. So in this tool path here, like I said, this is not an ideal tool path for this part, but what I wanted to show you guys here is you guys can go off of any sketch that you create and have it follow, have your tool path lines follow that sketch to a T. So which is real handy. Now, typically on something like this, if we switch it over, if we didn't want this weird shape that we drew in there, what we could also do is go to our geometry, switch up our edge curve, and we'll chain this guy around. And now we're starting, well, it looks like we're starting on the inside. And if we want to start on the outside, a little bit of refresher here, but we can do the flip step over. And now we're starting on the outside, working our way towards the center now. So it's keeping that square shape. So you can see our tooling lines coming through here, keeping that square shape going all the way through. And you can actually see we're rounded right here, but as it gets closer to the center, it turns more into the square edge. So any questions on this part in particular? Nothing coming in?
I don't see any questions coming through the questions panel, but I have one for you.
I was waiting for that one. Yep.
Can you show everybody watching at home or on YouTube what happens when your sketch geometry does not extend past the extent of the surface that you're cutting?
Oh, so if we were to draw a square just in the center here?
Or just take that arc that you currently have and make sure that it is shorter than that top surface that you're cutting.
So let's just go ahead and edit that sketch. Something short like that. And like that.
Yeah, on both sides. Yeah.
Okay. So now, go ahead and grab that new edge curve.
You may want to tone down the step over. That way we can get a high vis of the paths.
Go back to our standard 50 thou here. Okay, so when your geometry does not extend past, what it's going to do is it's going to go more with a linear, I don't know, going with the path. Let's see, how can I explain this? We're arcing right here, and then since our geometry ends right here, it's just going to continue straight over for us.
Yeah, so it's almost like it morphs between, you know, it'll try to do the arc pattern for as long as it can, and then it morphs into the to the surface, right?
Yep, exactly.
Okay.
So is that where you were getting at, Greg, too?
Yeah, I wanted a visual for everybody at home in case they do run across a scenario like this, that when they are doing parallel the curves in SolidCAM 2020 or previous versions, that if there's nothing to constrain that surface to that guide curve, then the toolpath is going to have more chance to
wander.
Something. Yeah, it's definitely going to wander.
Yep.
So just make sure that if you are trying to get something that's going to stay parallel to that curve, to make sure that the curve extends the entire surface.
Yeah, absolutely. And I mean, it's a simple, you know, if you guys are drawing sketch geometry and you are getting the wandering in a direction you don't want to, I mean, come in here, and you guys kind of seen it before, even if I go way past, don't want, no. So I'm going way past now. Hop out of our sketch. And this is why I love SolidCAM, because they can make a sketch and just repick it right away. And so long as you have your geometry up to tangent or past, it's going to follow that curve right up to a T. But like Greg was just talking about, if we don't have that area there, it's going to follow that curve where it stops right there. Then it's going to start wandering off into its own area. So the more you can make this tangent to the sketch face here, or just go past it. Anything tangent or past it will follow it to a T. If you are coming up short, then you will get some other tool path going in there, just because it lost its curve after that certain point. So. All right, one last part for you guys.
And again, as Kevin's bringing up the this next file, just to sort of reiterate what he said at the top of the presentation. Again, if there are any questions, just please feel free. There's a questions area on the GoToMeeting where you can just type those questions in. So we'd be happy to answer those. Just wanted to just make sure that everybody's aware of that.
Yep, absolutely. And if you guys don't ask it, Greg will get me on the zinger and get it some kind of advice for you guys.
I'm a man of the people.
again, we're going to do HSS here. Now, it is still set on my parallel to curve. So my drive surfaces that I would like it to cut, let's go here, here, and here. Now, the order that you pick these does not matter. So if I start up here, start down here, that order does not matter at all. Now, since we are I want to keep that circular pattern going there, what I'm going to do is I'm just going to grab a circle as my edge curve. But this will kind of go back to what we were just talking about with the tangency point of that sketch. So if we look straight down, I'm going to have a nice circular pattern going around this hub, but once I go outside that boundary, we're going to see something a little different. So, and I'll show you guys what we can do to get that circular going through the entire cut. So go ahead and grab a tool here. Save and calculate. Like I said, do it as a building block. Okay, so now we have a lot of retracts, but one thing I really like about the HSS is I can come in here and tell it that I would like it to do a spiral. So now what it's doing is it's starting on the top and it's spiraling down all the way through. Now, if we go to our links and we do a follow surface, and that's not coming up very good. Let me just turn off this face here. Okay, so now we're starting at the top and we're doing a nice corkscrew or doing a nice spiral working its way down. And how this would have looked, we were set to zigzag, is here is our start and end for each pattern. So as we go around, it's going to come around here, go up, come down, and then do a reverse. And then come up or move over, come over and go around again. So this is one nice thing about the HSS. Anything, long as you guys have the full HSS, you will have the option to do spiral. If you guys are running limited, you will only have zigzag and one way. But this toolpath here will get you a really nice looking toolpath finish in there. Now, just so I can try to stump myself, let's go back in there and add that surface in there. And then what I'm going to do here is just do a normal 2. And I want to throw a sketch on here of that circle. Okay, so we got our circle. Doesn't matter on the plane that it's on. My edge curve now, it's going to be, okay. Now if we save and calculate here, and we definitely have some linking. Let me start fresh on this one here. HSS.
Yeah, and Kevin, while you're doing that, I just kind of wanted to just kind of, just sort of speak out to the audience here just super quick. So if anybody's curious on what the differences are between, limited HSS and full HSS, we can go over those differences as well. You can just feel free to email any one of us, and we can talk about those differences and discuss which packages those are all included in. So, because everything here is modular, so you can kind of pick and choose what you want for functionality. I know most of you in the audience probably already have it. So, but if there are questions, we can discuss those as they come up.
Yeah, and if you guys don't have it, go buy it. I don't care what it costs. It's worth every penny of it. Shorten that guy up here. Okay. So now we got our nice spiraling down here. And what we're running into now is as it comes across that circle, but we're coming to a straight edge right here. So now if we go to our links and we will do a follow surface, see if that cleans up some of our, nope, that just gets a little bit messier. Let's do, and I'm shooting from the hip here. Go to our gouge check. And we'll enable that. And do our check surfaces. I'm going to tell it all adjacent. Okay. So now, I'm going to tighten up my tolerance here. We're still bouncing up and down inside here, which I don't really understand why. Let's go to our links here. And we'll do links between slices. Let's try doing a follow surface. Boy, that is just messy as can be. I'm trying to think here. What am I missing here?
I just think this is amazing, Kevin. I've never seen you actually stump yourself before.
It's always great when I do it when it's live and I got hundreds of people watching. All right, so when I add this surface in here, so let's edit, grab that, and I'm going to show the direction just to make sure we got all our arrows pointing out. That looks good, that looks good. But I don't have an arrow for that last surface. Okay, now let's try. Okay, for the life of me, I am not seeing the direction arrow for my phase 4. So what I'm going to do
Kevin,
is...
we have a suggestion from the audience. Would you like to hear it?
Oh, absolutely.
Okay, so Jason Beach says, why not just do a copy surface extend to have a projected geometry?
Okay. Let's try that. I'm just baffled why that's not working. We'll do Jason's idea here in a second.
And I think if this works, we might have to send Jason a t-shirt and a hat.
Yeah. Do you like how Greg is so quiet right now? Just laughing.
Oh, he's loving this. He's loving this.
You just took my job on stumping you, so.
Man, I cannot. Okay, so all else fails, start fresh. So HSS. Okay. Now I think what Jason is saying is do the extend trim. Tool select. And we'll go to toolpath parameters, extend trim, side extension. Let's just do 200% of the tool. Actually, it's going to be on the end, 0. Okay, so now, obviously we need to go farther. Okay, so now we got that toolpath going around, and let's switch this over to spiral. And as you guys can see, at every change that I'm making, I am saving calculating. Why? Oh, geometry.
Now, I may be wrong here, but I took Jason's comment as to create surface geometry that would extend, like you were just filling out that dome with the surface geometry and then using that as your drive surface.
Okay, you got me lost now. Say that again.
Create surface geometry that would represent that dome. Instead of trying to do it through the toolpath, just create a surface that mimics what you're trying to do, and then drive the toolpath based off that surface.
Yeah, and he just said creating the surface was my intent, but the toolpath extend is a cleaner solution.
Okay. Greg, you're taking keyboard and mouse here because I'm still lost on what you're.
Well, all he's looking for is, instead of having that hex cut into that surface, just have a fully round surface.
Oh, gotcha. Okay. So in that scenario, it still bugs me that way that's not working. Okay, we're gonna try something here.
Well, either way, this is a good exercise. I mean, this really shows, the alternatives to, if there is a part that's challenging, then, it really kind of shows off the ability to, to deal with those challenges. So.
Yeah. So what I'm doing here is, instead of following one curve, I'm going to tell it to start up here as a circle. and end down here. So this is a different toolpath that we're going to be covering in 2 weeks, but let's see if we get a better result here.
So wouldn't this kind of be essentially morphing between two curves, Kevin?
Yep, and that's what I actually selected here. So what I told it to do is morph between two boundary curves. So this is one curve that we chose at the top. So we're going to go from a circle down into our hex shape right here. And like I said, we'll cover this in a different class, but yeah, see, that looks much better. So in this particular part here, this is where the morph between two boundary curves would work much better than a parallel to a geometry curve. So like we're saying, we're told it to start up here and morph into this curve down here. So as you can see, we're right in the center here. We're still in the circular, and then it slowly starts curving into that shape that we selected there. So that one is going to be a better path there. And like I said, we're going to be covering the morph between two boundary curves in, let's see, 1, 2, 3 weeks. That we'll be covering that one. So, but for that particular,
so in case you guys didn't want any spoilers,
yeah,
too late.
Yeah.
Well, and my apologies for overstating the obvious. I'm looking at the title block for that window, and it's exactly what it says. So I didn't even notice that. Sorry.
Good. But any other questions from anybody? Sorry on that one, I got a little stumped up there. But any questions on the parallel to an edge curve, or anything with the HSS, with the constant Z, linear, hatch that we've covered so far in this HSS series?
Yeah, Kevin, so far the Jason's been the only one with well, they were more suggestions rather than questions, but other than that, no, nobody has stated or asked a question.
Well, Greg, I'm going to leave this one on you.
Well, since we're still in what's going on territory, what if we were to apply the constant Z toolpath to that circular geometry?
Okay. So now with constant Z, we don't have to pick a drive curve. But all right, so our geometry, do a show, is still our same geometry as before. I'll turn off the path here. Tool, still going to be the same. Tool path parameters, we'll still at our 50 thou. We can go to our sorting, switch this over to spiral.
Well, let's just do one way for right now. Let's take as many parameters out of it as possible.
Okay. So with the constant Z in a perfect circle, we are going to achieve the same results going through there. But
now clean up the links again.
Well,
I'm curious about this one.
yeah.
No, it doesn't look too bad. A little bit flat there on the sides, but provided that that material's been cut away.
Yep. And I guess at that point, what we could do is in our gouge check, we could turn on and just do a check surfaces. And once again, we can tell it to do all adjacent and to leave maybe 10th out in there. So now that tool will not come in contact with those faces that we have told it by 10th out. So if you guys were coming in here, maybe you rough this out with 3D eye machining, and then now we're doing our surfacing, and then our last cut would be a profile operation, cleaning up that hex going all the way around. So pretty similar toolpath there. And if we wanted to clean up a little bit more, is we switch this over to spiral.
I do have a quick question for you, Kevin,
Absolutely.
when you're ready.
Yep.
Jason's asking, does constant Z also have spiral linking?
Like the cut method right here?
I guess he's specifically asking about linking. Yeah, he said yes, you're on it. Yep.
Oh, okay. Yeah. So any of these operations that you will see in here. Now, if you guys are looking, you open up HSS and you're only seeing parallel cuts and it says linear constant Z. That means that you are running the limited version of HSS. Now, there's a lot of downfalls of the limited. So with limited, you're only going to get your sorting method. You're going to have one way or zigzag. You're not going to be able to do advanced gouge checking in there, as well as your roughing and more, or your multi-passes, your translated, all that will be all grayed out. So if you guys are watching this and you're trying to do a parallel to a curve and you're not seeing it in there, that's because you're running the limited. And reach out to your account manager or reach out to myself and we can get you a price to add that on there. It is worth every penny, but linear, if we're doing linear path here, to get to Jason's question, go to our sorting, you will have zigzag and spiral, as well as in your constant Z, you will also have one-way zigzag and spiral. So every operation that is in HSS will have the spiral capabilities in there for you. So
Perfect.
Provided that it has sections like that.
yeah, yeah.
Like a user-defined projection may not.
Yep. But no, great questions. All right, any other questions before we wrap this up for tonight?
So far, that's it, Kevin.
All right, so definitely come back next Tuesday. We will be covering the parallel to surfaces, and then we'll get to that morph between boundary curves, like we were just showing you in our messed up part there, and then keep going through the HSS series. So definitely come back, and if you guys are trying to register, just go to the homepage, make sure you got the American flag, come to webinars, KevCAM, and then you guys can sign up for right here as well. And as well as if you guys do have ideas, send those over to me via email, and we'll get those added in there as well. And then for everyone that is watching this later date on YouTube, my email address is below in the description of the video too. So, all right, everyone. Thanks again for attending, and we will talk to you guys next week. See you, everyone.
Take care, everybody.